Let's see an example of conveyor line. This example has been created with predefined objects provided with Virtual Universe Pro. Let's launch the simulation. As we can see, objects are subject to gravity and also push each other. All of this is managed by the physics engine integrated to Virtual Universe Pro. Let's see another example. This example was entirely created from importing an assembly from SolidWorks, which is a CAD software usable for creating projects for Virtual Universe Pro. In this example, we can see an axis simulation with acceleration and deceleration. And also objects pick and place. We can move objects by grabbing them. Let's see the configuration of this project. In which we found the different items, especially all parts with the structure as defined in the CAD software. In addition, we will find some other items like HMI, and also virtual controllers. In this case, a virtual controller is used to define the program for the machine. This could of course be done in a programming into a PLC. These virtual controllers can also be used to add some intelligence associated to objects. In this example, a virtual controller is used to create a logical equation causing the glass doors opening when clicked on with the mouse. Now let's see how to import data from CAD software. I'm going to open a file exported from SolidWorks. The file format is 3D XML, which is one of the export format of SolidWorks. The PC structure is the same than the structure defined in SolidWorks. It is possible to modify the structure by making a drag and drop into Virtual Universe Pro. Now let's define a move for this object. I'm selecting the piece to move and then open a motion assistant. I have to define the mode for the move, the axis. I can define visually the maximum position. In this mode, the move is defined simply by a time for making the move in a way and in the other way. I can try the move to see if it's okay for me. In this assistant, I'm also able to create sensors. I'm defining the name of the sensor. I can define the range. I'm going to add a max sensor. I can also define the range for this sensor, and I can make a test to see if the state of these sensors is okay. When everything is okay, I can leave the assistant, and then automatically behaviors are created and associated to this object. When I launch the simulation, I can see the states of each behaviors and simply double click to change the state, and I can see the states for the sensors too. Typically, the move behavior will be associated to an output of the PLC, and the two sensor behaviors will be associated to inputs of the PLC. Let's see an example of motion configuration in example. Let's have a look at the configuration of this cylinder, which is used to block these red boxes. Just open the motion assistant. As we can see, the main concept is the same. Can make a try. In fact, this concept is general in Virtual Universe Pro and can be used to create move even if we have to create complex motions. Let's export our electrical pusher as a reusable object. Simply select a file name. Now we are going to create a new project and reuse our electrical pusher. So create a new project. We are also going to use predefined objects, a conveyor, a source of boxes. I select the position. I can also modify this object property. The automatic send period, 3 seconds. Let's try it. Okay. Now we are going to add our electrical pusher. Simply go to the place where the file has been saved. Open it. And then I can, exactly in the same way as the predefined objects, define the position. Okay. Now I can add a sensor. So let's return to the library. Select sensor. Define its position. Okay. We can make a test simply to see if the sensor is working. Seems okay. Now I'm going to write a small program to make the pusher move when the sensor is true. So let's add a virtual controller, add a program into this controller, and create with SFC just a little program. I can directly select the behavior. So for the test it will be here. I can then create a link between this behavior and the transition. Add a step, make a link on here, add an action. It will be the move behavior that I have defined for my electrical pusher. I can then test the maximum position of my electrical pusher. This is a sensor function that I have created when I define my electrical pusher and plug it to the transition. There is a small program. I can directly test it. Okay, so it seems to work, but there is a problem with the pusher. This is simply because I have not defined the right property for it. I'm going to select this object and go to the physics properties and use this property, use physics, and select true. I can make a new test to see if it works now. Okay, so we can see this is better, but there is now a problem with my small program. I can make very quickly a modification. I'm going to add a falling edge test on the detection sensor and make a new test immediately. You can see this is very quick to go from the modification to the test mode. We can see that there is a problem here. So I'm going to modify directly the drawing by selecting the object, and I can directly make a modification, change the size of this object, and then make a new test immediately to see if my modification is okay. Okay, now it seems very nice. Now we are going to open an example showing an electric diagram simulation. Let's run the simulation. Now I'm going to open the diagram. And I can click on the 3D items and see the result on the diagram. Let's open this box. Now I'm going to simulate a shortcut with this switch, and we are going to see that the circuit breaker is going to break the circuit. Let's click on here. We can see the shortcut on the diagram and also the result on the circuit breaker. Let's click here. I cannot switch it on. I switch off the switch on here, and then of course I can switch it on again. Let's open another example with pneumatic simulation. A simple cylinder. Let's launch the simulation and open the diagram. On here we can see the PLC, the sensor part, and the cylinder with directional valve. Let's click on here and we can see all of these items working together. I can click on the rod and we can see that the rod also moves into the diagram. I can break a link directly on here, and I can see that the process is not running correctly now, because of course this sensor does not work anymore. Let's have a look at some other examples. A very interesting machine with some boxes using only gravity. Let's launch a simulation. We can see the very interesting behaviors provided by the physics engine. Let's see one more example. All these predefined examples are provided with Virtual Universe Pro, of course. This is a sorting sample. This sample is used to find if an object is upside down. If the cylinder can go completely down, then the piece is okay, and if it cannot, like this, then the piece must be ejected with this other cylinder. One more example. This example is an unstacker. One more time, the physics engine allowed to have a very realistic simulation. This other example is very interesting regarding physics behaviors. Let's open an example in the batch processing field. We are going to see how to create a failure simulation on this sensor. Let's select the behavior corresponding to this sensor. Select the type of failure. Okay. Now we're going to run the simulation. At this time the failure simulation is not activated, so everything is working. I'm activate the failure simulation with a keyboard shortcut. We can see here in the caption of the window that it is activated, and then of course the process is stopped. I can deactivate the failure simulation, and I can see that now it works. Okay. The failure definition can be protected with a password if the goal is to make somebody search for the failure, of course. Now let's see how we can import constraints from SolidWorks in this small example. So let's import from SolidWorks. This option permits to import directly as opened assembly in SolidWorks. This checkbox allows to import constraints. Let's go. Okay, now we can use an assistant to select the properties of this move. Simply define the time, and as we can see, Virtual Universe Pro is reusing completely the SolidWorks constraints. I can also add sensors immediately by one more time reusing the min and max position as defined in SolidWorks. So with this importation, it is very easy to have directly the different moves recreated in Virtual Universe Pro, and of course the behaviors usable directly. Let's see a simulation connected to a real PLC programmed with machine. Here we can see the program. Let's connect to the PLC with Virtual Universe Pro, and then we can have the simulation in both the program and the virtual machine. Virtual Universe Pro can be connected to the main PLC brands, Siemens, Mitsubishi, etc. The connection can be made directly with the PLC or with most of the PLC emulator like PLC sim for Siemens.